Welcome. In this session, we will explore how to strengthen the security of your 𝗙𝗙𝗻 email server using a practical configuration playbook. Email infrastructure today faces constant threats including spam campaigns, phishing attacks, credential compromise, and domain spoofing. While 𝗙𝗙𝗻 email server already provides powerful built-in protection, the real strength comes from how administrators configure its security controls. In this guide, we will walk through 10 essential spam defense strategies that help protect both inbound email traffic and outbound mail integrity, ensuring your domain remains secure, trusted, and reliable. Email attacks are evolving rapidly. Today's spam is no longer just random advertising messages. Many attacks are carefully engineered campaigns designed to compromise accounts, distribute malware, or impersonate trusted senders. 𝗙𝗻 provides a strong foundation with built-in spam filtering, antivirus integration, and authentication controls. But achieving maximum protection requires multiple security layers working together. Inbound defenses must filter malicious emails before they reach users. At the same time, outbound monitoring must ensure compromised accounts cannot abuse your server to send spam. This guide focuses on strengthening both sides of that security model. The first step is optimizing the spam filter scoring system. Navigate to spam filter settings. Every incoming message receives a spam score based on content analysis, heuristics, and reputation checks. Messages that exceed a high rejection threshold, for example a score of 12 or higher, can be rejected immediately during the SMTP session. Messages with lower scores are allowed into secondary inspection layers such as DNS block lists. Finally, messages exceeding the final threshold, commonly 5 points, are handled using spam filtering rules. Correct threshold tuning ensures suspicious emails go through deeper analysis rather than bypassing protection. 𝗙𝗻 includes an adaptive Bayesian spam filtering engine. This system analyzes statistical patterns in email messages to identify spam based on learned behavior. To train the system, organizations can provide samples of confirmed spam messages and legitimate non-spam emails. These samples are used to refine the classification database. A best practice is to create designated training folders where users can submit spam and non-spam samples. Administrators should periodically review these samples before feeding them into the training engine. With continuous learning, Bayesian filtering adapts to your organization's real email traffic patterns. Allow lists are useful, but they must be used carefully. An allow list allows messages from trusted senders to bypass certain spam checks. However, administrators should never add internal domain addresses to the allow list. If local addresses appear there, attackers can spoof those addresses and bypass security controls. Because allow listed senders are treated as trusted, malicious emails may land directly in user inboxes. For best security, restrict allow lists only to verified external partners and audit them regularly. Before analyzing message content, 𝗙𝗻 can evaluate the sending server itself. This process is called connection screening. First, 𝗙𝗻 performs reverse DNS verification. This confirms whether the sending IP address correctly resolves to a legitimate mail server hostname. Many spam bots fail this check. Second, enable DNS blocklist lookups under spam filter 𝗙𝗵𝘁. These lists maintain global databases of known spam-sending IP addresses. By blocking suspicious hosts at the connection stage, the server stops many attacks before they even reach the spam filter engine. One of the most critical email security risks is becoming an open relay. An open relay allows attackers to send spam through your mail server. To prevent this, enable relay restrictions under security settings. Ensure the option "Do not allow message relaying" is enabled. Next, configure 𝗵𝗄_SHIELD under Security Sender Authentication 𝗵𝗄_SHIELD. This feature associates trusted internal IP ranges with your domain. If a message claims to originate from your domain but comes from an unauthorized IP address, it is rejected. Together, these controls prevent both relay abuse and internal domain spoofing. Even secure systems may occasionally experience compromised accounts. When outbound spam occurs, rapid investigation is critical. First, enable message ID headers through Setup Preferences headers. These unique identifiers allow administrators to track individual messages. Next, review the SMTP outbound log file named SMTP_out_log. Locate the suspicious message and copy the message ID. Then search the SMTP inbound log to identify the originating session. This reveals the sender's IP address, authentication status, and account details. If an authenticated account is involved, immediately reset the password. Spam filtering alone cannot stop modern phishing attacks. Many attacks today use targeted spear phishing techniques that impersonate trusted organizations or internal employees. Research shows that approximately 95% of enterprise attacks originate from phishing emails, and most data breaches involve some level of human error. User training is important, but technical defenses must also be implemented. The most effective protection against domain impersonation is the authentication triad: SPF, DKIM, and DMARC. These technologies verify that emails truly originate from authorized sources. SPF stands for Sender Policy Framework. It allows domain owners to specify which servers are authorized to send email on behalf of their domain. SPF is implemented as a DNS-TXT record. The record lists approved IP addresses or mail servers. For example, a typical SPF record begins with v equals SPF1, lists authorized sending hosts, and ends with -all, which indicates a strict failure policy. Within MDaemon, enable SPF checking under Security Sender Authentication SPF verification. This allows the server to verify whether incoming messages originate from authorized servers. DKIM stands for Domain Keys Identified Mail. It uses cryptographic signatures to ensure message authenticity and integrity. When DKIM signing is enabled, MDaemon attaches a digital signature to each outgoing email using a private key. Receiving servers retrieve the public key from DNS and verify the signature. This confirms that the message truly originated from your server and was not modified during transit. To configure DKIM, navigate to Security Sender Authentication DKIM Signing. Generate the key pair and publish the public key in your domain's DNS records. DMARC adds a policy layer on top of SPF and DKIM. When an email arrives, receiving servers evaluate SPF and DKIM authentication results. Then they check the DMARC policy defined by the sending domain. DMARC allows administrators to specify what should happen when authentication fails. Possible actions include monitoring only, quarantining suspicious messages, or rejecting them entirely. DMARC records also allow reporting, which helps administrators monitor how their domain is being used across the internet. This visibility is extremely valuable for detecting spoofing attacks. The final strategy focuses on active threat detection and system maintenance. Enable antivirus scanning in the security menu to inspect incoming messages for malware. Next, activate spambot detection under security screening. This feature identifies patterns typical of automated spam campaigns, such as multiple IP addresses attempting to send mail through the same return path. Finally, enable automatic software updates under Setup Preferences Updates. Keeping the server updated ensures protection against newly discovered vulnerabilities. When combined, these 10 strategies create a defense-in-depth security architecture for MDaemon. Inbound defenses stop spam before delivery through scoring optimization, Bayesian filtering, allow list controls, and connection screening. Outbound protections prevent server abuse using relay restrictions, IP shield, and spam tracking. Finally, authentication technologies, SPF, DKIM, and DMARC, ensure sender legitimacy and prevent domain spoofing. Together, these layers create a resilient and secure email infrastructure. 𝗙𝗵𝘁 Limited is the official distributor of MDaemon technologies in Bangladesh. For businesses implementing secure email infrastructure, our staff offers comprehensive support. 𝗙𝗵𝘁 will assist you with your technical consultations, proof of concept deployments, pre-sales solution discussions, and implementation support. For technical inquiries or solution assessments, contact 𝗙𝗵𝘁 Limited or your trusted system integration partner. Visit www.tkdistry.com. You can also email us at partnership@tkdistry.com or call us on +88 016 1136 5252.